Now we are going to the IBDP HL of the Gibbs Free Energy. Now we derived from the entropy, and ultimately we got what? We got a new thermodynamic parameter that is called a Gibbs Free Energy. Delta G is equal to minus delta H system minus T delta S, right? Isn't it? And it should be less than 0. Means what does it tell? It tells you that for a spontaneous reaction, right? For a spontaneous reaction, Gibbs free energy should be negative, right? It should be negative, right? Now come to this thing. Now for a non-spontaneous reaction, right? For a non-spontaneous reaction, Gibbs free energy should be positive, right? It should be positive, right? So this is very crucial for us to understand that whenever we are seeing the Gibbs free energy, Gibbs free energy tells you about the spontaneity of the system. Very important. Everywhere this will be used. In your equilibrium, in your redox, right? This will be used. Gibbs free energy should be negative for spontaneous system. Now come to this thing. What does Gibbs free energy tells you, right? What does Gibbs free energy tells you? Gibbs free energy tells you that how much amount of the quality of the work that can be extracted from a heat source, right? Suppose I'm telling you two system is giving out heat, same 2000 kilojoules and 2000 kilojoules, right? Isn't it? Right. Now, from these two different heat sources, we are getting the same amount of heat. In a heat, you have got two parts, right? You have got usable heat, isn't it? And you have got non-usable heat, right? Isn't it? Fine. This usable heat is converted to useful work. Is it clear? Did you get this thing? This non-usable heat cannot be converted to work. Did you get this thing? So in a heat which is released, right? I hope that you've seen that, right? Do you see that in the same hatchback car, right? In the same hatchback car, two hatchback cars, right? Same hatchback cars, right? One is giving you 22 miles per liter. One car is giving 19 miles per liter, right? Isn't it? The two cars is having the same engine size, same specification, but two brands of the car. Why? Because in the first car, the usable heat is more. Usable heat will be transferred to work done. So Gibbs free energy tells you what? Gibbs free energy will be telling you the amount of the quality of the work, or the amount of the work that can be converted from the heat. What does H tells you? H tells you the quantity of the heat. Remember this thing. It tells you the quantity of the heat. Enthalpy tells you the quantity of the heat. What does Gibbs free energy tells you? Gibbs free energy tells you about the quality of the heat, right? The quality of the heat. We can see that in this car, both the cars is giving out 2000 kilojoules of heat, right? But in the car number 1, the amount of the useful heat means the quality of the heat is better. That more mileage is given, right? Is it clear? Gibbs free energy tells you about what is the measure of the quality of the heat, right? Not all the, and delta H tells you what the quantity of the heat. Heat has got two parts: usable heat and non-usable heat. The non-usable heat cannot be transferred to work, right? So Gibbs free energy tells you about the quality of the heat that is coming from a system, right? And more importantly, it will be telling you about what? It will be telling you about the spontaneity of a reaction, right? If it is negative, the reaction is spontaneous. If it is positive, it is non-spontaneous, right? Now come to the part. Now this delta G is equal to delta H minus T delta S, right? This. And over here you have to understand that this T will be acting as a tap. How? I'm telling you. Now you have to do some approximation over here. Now at low temperatures, right? At low temperatures, what happens? At low temperatures, you have to understand that one of these we have to cancel out, right? Which is lower, right? Which is much lower than the other. We have to cancel out or approximate, right? At low temperatures, what happens? When the temperature is very low, right? Very low. At very low temp, what happens? T delta S also is very low, right? You are multiplying T, which is very low, multiplying with delta S. The multiplication factor will be very low. So we have to approximate what? delta H will be much greater than T delta S, isn't it? Did you guys see? Delta H will be much greater than T delta S. So here we can do what? We can approximate delta G is equal to delta H minus T delta S. At low temperatures, the delta H is much more value than T delta S. So we can approximate this. We can cancel out this. We're getting what? We're getting delta G is equal to delta H, right? Right? At low temperatures, now we have to understand that at particular low particular temperatures, the T delta S is very small. We can approximate. Celia, now to tell me that at low temperatures, what will be the sign of delta H in order to make the reaction spontaneous? Negative or positive?
It should be positive.
Wait, delta G spontaneous is what? Tell me.
If it's negative.
It is negative? And it is spontaneous, and positive is what? Is non-spontaneous. So what should be the sign of delta H so that the reaction is spontaneous? Negative or positive? You said negative. Now what about you, Kavya? Delta H sign should be negative or positive? Kavya, come back quickly. Kavya? Hello? Negative. You are saying K. What's your take? K?
Negative.
Negative. Yes. Is it clear to you? So we can tell that all what is delta H negative? Exothermic reaction. We can tell what? We can tell that all exothermic reactions, right, can happen at low temperature, right? Can happen at low temperatures, isn't it? Is it clear to you? Suppose there's ice, right? There's ice there in a forest, right? Can we start a fire with a log of wood? Yes, right? Although the temperature is low, but this is a exothermic reaction, burning of wood. Yes. So all exothermic reactions can take place at a lower temperature, right? Is it clear? Now come to the second point. If the temperature is high, right? If the temperature is high temperature, when the temperature is high, we have to understand that what? If the temperature is high, right? Delta G is equal to delta H minus T delta S. If the temperature is very high, right? What does it mean? You have to approximate one. T delta S means T is very high. You're multiplying T with delta S. So multiplying T with delta S will be giving a bigger value, huge value. So T delta S will be far greater than delta H. Is it clear? Did you get this thing? Is it clear to you? So whenever we are seeing at high temperature, what happens? This value, this multiplication, T is very high, right? At high temperatures mean T is very high. The multiplication of T delta S will be one approximation we have to make. We have to cancel one, right? Just learn this trick. So we cancel out this, right? Just give me a minute. Just give me a minute. Just give me a minute. I'm very sorry. Just wait. At low temperatures, this is it. At high temperatures, we are not cancelling this. I'm sorry. My bad. At high temperatures, T delta is very high, right? So what this value is very small, right? This value is very small. So we cancel out this, right? So what we are getting? Delta G is equal to minus T delta S, right? We are getting this, right? Isn't it? This equation we get, right? So this is very important for us to understand that what we are getting at high temperatures, the spontaneity of the reaction depends upon what? Depends upon the entropy, right? Depends upon the entropy, right? Delta S, isn't it? Now, K, tell me, at high temperatures, what we got? That the spontaneity of a reaction depends upon minus T delta S, right? Ultimately depends upon delta S. Now tell me, K, if the delta S is positive or negative, the reaction will be actually spontaneous or not? Which one? For the reaction to be spontaneous, the sign of delta S should be what? K? Will be positive, you are saying, K? Now, Kavya, what will be the sign of delta S? Kavya?
Positive.
Positive. And Celia, the sign of delta S will be what?
Positive.
Positive into negative will be negative. Yes. So it will be positive, right? So this is very important that what we can conclude? We can conclude that high temperature, which reaction happens? Endothermic reactions, right? We can tell that all endothermic reactions, right? All endothermic reactions will be spontaneous, right? Will be spontaneous. Where it is having delta S positive values, right? The positive value will be there, right? So we're getting these questions, right? Isn't it? Now, if we do a question quickly, right? So you can understand, right? See, now did you understand this trick? One part you have to approximate, right? One of them will be approximate. Suppose I'm going to this question quickly. See, now you all join with a pen. This is very easy, right? This is very easy. Don't worry. This part is super easy. Just 1 minute. I'm just trying to rub this part so that you can all do it. Over here. So here, here. I'm coming one by one to you, huh? Oh, this is a bit low. This is this. Okay. Delta is this. It's here. Okay. Now, first question to K. Okay. Now tell me one thing. That if you're having the T, right? The T low. Which one to approximate? Can you attach your pen, please, quickly? Okay. Can you attach your pen, please, quickly, and tell me? I'm making some white space over here where you can write, right? Everybody, right? So I'm just showing you one part, right? You can follow, right? This is very easy if you can understand quickly, right? You will be understanding. You see, I'm just going to the pen, sharper pen. Okay, what will do? Delta G is equal to delta H minus T delta S, right? Now, K, tell me if the T is low, which of these values we have to approximate? Can you connect your pen, please, quickly? Okay. Yeah. So this we have cancel out, isn't it? So delta G is equal to delta H, isn't it? So now tell me, the spontaneity of the reaction depends upon what? Only on the enthalpy sign. What is the enthalpy sign over here? Can you check? Does it depend upon the delta S? No. So this is not required. Whatever the value is, it's positive. So write down over here, delta G is positive. So it is spontaneous or non-spontaneous?
Non-spontaneous.
Non-spontaneous. Very good. Now coming to Celia. Celia, here you go. When the T is high, now tell me, Celia, which part to approximate? Tell me. Delta G is equal to delta H minus T delta S. Which part to approximate? When T is high? Yeah. So ultimately the reaction will be what?
Negative.
Delta G is equal to minus T delta S, right? Isn't it? Fine.
Yes.
Is it clear? At high temperature, does it depend upon the on the enthalpy? Does it depend upon the enthalpy? No. So we cancel out this. It does not depend upon the enthalpy. What it depends upon? Okay. Sorry, Cecilia. It depends upon the sign of the entropy, isn't it? Entropy. Now, can you tell me what is the sign of the entropy over here? What's the sign of the entropy given?
It's positive.
Positive. So now tell me what will be the sign of delta G?
Positive.
Negative is sign over here. Negative and positive. What will be the sign? Negative into positive gives you, tell me, negative, right? Minus into plus will be equal to give you minus, right? Isn't it, Celia? Did you get this thing? Minus is there over here, see?
Okay, so it depends on temperature as well, not only.
No, temperature is high, so it depends upon temperature. So we rearrange this equation and write down. If the temperature is high, this value is high, right? This value is high. So we approximate delta H, right? We approximate delta H. We cancel out this, right? We're getting minus T delta H, right? So this is the only equation we're getting when the temperature is high. Now we have to focus upon what? We have to focus upon only about the sign of the delta S, right? Because ultimately this is the reaction we're getting. Delta G is equal to minus T delta S in high temperatures, right? Only focus upon this, right? Isn't it? Delta S sign is what? Positive. Positive into negative gives you how? Negative. Negative what? Spontaneous or non-spontaneous?
Spontaneous.
Spontaneous, right? Now come to Kavya. Kavya, now connect your pen quickly. Kavya, have you joined with the iPad or what? Or no?
Just fine.
Okay, you have not joined with the iPad? Okay. Sweet.
So I've joined with me.
Thank you. Now jump in. K, you will be next, right? K, you'll be next. Celia will be next, right? So follow this, right? Now do this. If the temperature is low, what does it tell? What does it tell you?
So delta G will be positive, right?
Here, write on the board, write on the board. What thing to approximate first? Tell me. What thing to approximate from this? If the temperature is low, means what thing to approximate? Delta H or T delta S? Which one to cancel? Which value will be smaller? Tell me.
T delta S.
T delta S, you cancel out. Ultimately, what happens? Delta G will be delta H. So
Yeah.
is the spontaneity of the reaction depends on entropy anymore? No. Celia, did you get this thing? How to do this questions, right? Delta G is equal to delta H at low temperatures, right? It does not depend upon the sign of the delta S, whatever. So we don't need this sign, right? Now tell me, Kavya. Tell me.
So it'll be positive, right?
Is it positive? So this endothermic positive. Now what will be spontaneity then? Tell me quickly.
Non-spontaneous.
Non-spontaneous, right? Now come to K. K, quickly do it. Next question for you. Quickly do it. Quickly pick up the next question. K.
The temperature is high, so
High.
you approximate the delta H.
What is the equation coming? Write down over here. Equation quickly. Fine. Yes. Minus T delta S, right? Minus T delta S. Perfect. Now tell me, does this depend upon the delta H value? No. We don't have to see this delta H. What is that, right? No. Now tell me, delta S is negative over here.
Delta S is negative, so then delta G will be positive, so it's non-spontaneous.
Write down spontaneous, non-spontaneous, right? Now, Celia, this is for you. Now tell me. This. Quickly tell me.
Yeah, so the temperature is going to be high.
So what value is more?
Delta
Write down, Celia, write down, fatafat. Right. Very good. Write down in the next, delta G will be equal to what? Rewrite the equation quickly.
Yeah, so now delta S is positive.
Now delta G will be what? Delta G is equal to minus T delta S. First write down. Delta G is equal to minus T delta S, right? Isn't it? Right? So this positive
and negative.
Gives you what? Negative positive multiplication gives you?
Negative.
Negative, right over here, negative. And what was the sign? The spontaneity will be what?
It is spontaneous.
Yes. Perfect. See? Lovely. So this is the part we have to understand, right? Lovely. Brilliant. So yes. Now just 1 minute. What I'm trying to do is that I've given some questions to you. Yeah. This 64, right? 64. I'm just coming within a minute, right? Will be resulting in a reaction spontaneous at a low temperature, right? Just take one by one, right? One by one, right? Now tell me, K. Now if you have a low temperature, right? How can you write down the equation? Can you write down? Delta G is equal to what at low temperatures? Delta G is equal to delta H, right? Everybody is on the same page, right? At low temperatures, delta G is equal to delta H. Now this is a two-part question, right? Now delta G is equal to a spontaneous, right? Is spontaneous at low temperature. What will be the sign of delta H, Celia? For the reaction to be reaction spontaneous?
Negative.
Celia? Negative. So we pick out negatives and we cancel the positives. Is it clear? Now to Kavya. Kavya, tell me, non-spontaneous at a high temperature. At a high temperature, how should we write down the equation? Kavya, delta G is equal to what? Should be? Tell me. At high temperatures? Delta G is equal to delta H minus T delta S. We at a high temperatures, what happens? This is very high, very big value, right? So we have to approximate this. We have to cancel out this. At high temperatures, delta G is equal to minus T delta S. Now can you tell me what should be the sign? Can you just guide me, Celia? Oh, sorry, K. What should be the sign? Being non-spontaneous at high temperatures? See, okay. Tell me.
Delta G or delta H? S.
S.
Positive.
Tell me for a non-spontaneous delta G should be positive, right? So they are saying negative. What about you, Celia?
Negative.
Okay. And Kavya, the same. Is it clear? Yes. Is it clear to you now? How to solve this kind of questions, right? It's very easy. Two-part question to solve like this, isn't it? So we got to know, right? We got to know how we can handle this type of questions, right? Now coming to the next part, right? Now if you see that whenever we are getting a particular question of delta G, ultimately delta G, as I have told to you, and the shortcut delta G is equal to P minus R, right? If you're asking the delta G reaction, it is P minus R. Products Gibbs Free Energy, Total minus reactant Gibbs free energy. Delta S reaction is how much? P minus R, right? We discussed this, right? Now come to this thing. Now, if you see that whenever we are giving delta, whenever we are giving GF, right? So it's very simple, right? That always remember, okay, and another thing you have to remember, please, that is delta G will be 0 for elements, right? Elements, right? Elements will be having 0 delta G. So this will be having, see, 0, right? Aluminum is an element. Uncombined, yes, 0. Is it clear? Now simple. It will be delta G reaction will be P minus R, right? So we do what? This aluminum oxide is how much? Minus 152, 1582, right? This is we are getting. And over here, Fe2O3 is how much? Fe2 is how much? Minus 742, right? So this is P. We subtract it from R, right? Isn't it? We are getting what? We are getting delta G reaction. Always remember an important trick I'm telling you. Delta S unit is joules per mole. Delta G is a kilojoules per mole. Remember this trick, right? And delta H will be kilojoules per mole, right? Isn't it? Learn this trick. Remember this trick. Now going to this point, right? Now if you see that whenever we are seeing this reaction, right? See, we are doing like this. See, we are doing Gibbs free energy of the products minus Gibbs free energy of the reactant, and we're getting this very easy question, right? Now, if you have got a question like this, right? See, now see, if you have got a question like this, see, calculate the delta G reaction at 298 Kelvin, right? Calculate the delta G reaction at 298 Kelvin for thermal decomposition of calcium carbonate, right? Thermal decomposition of calcium carbonate from the following data, right? Isn't it? Now, over here we are seeing what? We have to use this equation, see, delta G is equal to delta H minus T delta S, this part, right? Isn't it? We have to use this equation. In this equation, we are seeing what? First, we have to calculate what? First, we have to calculate the delta H reaction over here. Delta G reaction will be equal to delta H reaction minus T delta S reaction, right? First, we have to calculate what? First, we have to calculate the delta H reaction over here. Right? See what values are given over here. HF values are given and entropy values are given. Now, please try to write it down quickly. What we are seeing that it will be P minus R, right? So first we have to find out delta H reaction. We are plugging in from HF value. See, you won't be spoon fed. I'm telling you, these values won't be given. You'll be given that calculate the delta G reaction, right? From the table in the data booklet, right? Right. Suppose they are giving that from the table 12 of the data booklet. Now, Kavya, can you tell me that which values is given for H, HF or HC? Which values are given in the table number 12?
HF.
Kavya, HF values are given. Did you get this thing? K, right? Suppose they ask you that calculate the delta H reaction from table number 11 of the data booklet. Which values you are picking up? Can you tell me, K? Which values you have been asked to pick up? K? Bond enthalpy values. What will be the equation you have to plug in? Tell me, K. Reactant minus product, right? Is it clear? Please write this down, please. Huh? Is it clear to you? Celia, did you get this thing? Suppose you're asking you, Celia, that calculate the delta H reaction, right? Calculate the delta H reaction from the table number 13 of the data booklet, right? Which values you are trying to pull out? HC values. Reactant minus product. Very good, very good. Now you're through, right? Very good. Just learn this trick. This will be a very easy trick for you to quickly learn, right? So over here, we are finding out delta H reaction. We are first finding out what? We're first finding out the delta H reaction from the HF values. We are plugging in what? Total product you'll be doing, adding total. First add these products, sir. Most silly mistakes occur over here. And we are subtracting from the reactant, right? Total reactant we are getting, right? We are getting what? We are getting P minus R. We are getting a value over here, right? Now remember this trick. Whenever we are plugging in S values, what is the formula I've told you, K? If you're having delta S reaction, what is the formula? It's P minus R or R minus P? K?
P minus R.
P minus R. So you have to plug in P, but the main risky point is that S is in joules. delta H is in kilojoules and delta G is in also kilojoules. When you plug in delta S, right? I've numerously sent mails to this Pearson book. They have not corrected a printing mistake over here, right? There's a huge printing mistake over here. See, we are calculating the delta H reaction, P minus R. We did it, we got it. Now entropy, we are plugging the values, we are getting joules per Kelvin. Now over here, whenever we have, this is S, right? This is a printing mistake, right? T delta S, right? Now what you do over here, you have to divide this by 1000, right? Isn't it clear? To bring it to kilojoules. See, did you get this thing? What I'm saying, right? To divide by 1000 to bring it to kilojoules, because the unit has to be same, right? You have to have the same units, right? So ultimately we are subtracting this. This is kilojoules, but S is in joules. We have to convert to kilojoules, right? By 1000 we are getting kilojoules, right? And we are subtracting it. We are getting what? 130 kilojoules per mole, right? Is it clear? So this is very important for us to understand that whenever we are seeing this reaction, right, we have to just arrange it as it is, right? Isn't it? Now come to the part called as what? Come to the part called as the Gibbs Free Energy, right? The Gibbs Free Energy, right? Now, if you see that the Gibbs Free Energy, right? The Gibbs Free Energy has always to what? The Gibbs Free Energy has always to be negative, right? It has to be negative, right? In order for the reaction to be spontaneous, right? The Gibbs free energy should be positive for this reaction which is non-spontaneous, right? Non-spontaneous, right? So this is a very important trick we know, right? Trick we know. Now going to the next part, right? We have finished 50% or 60% of the HL, right? This is all about the Gibbs free. Now, Celia, can you send me a message, please? I'm giving a homework for you all, right? This. See, this thing you try to do at your homework. Celia, can you send me a message? Worked
Yes.
example, page number 257. Very important. Try it. It's very easy. If you cannot do, I'll be helping you. But try it once, right? Right? Fine.
What's
Try it.
the question?
This is PSN, right? PSN P, right? P 257, right? 257. PSN 257, right? Isn't it? Thank you so much. Just try out this equation, right? And always derive from the Pearson guidebook, right? Pearson guidebook straight away. And yes, the